To introduce industrial process about production of methanol. So for production of methanol, it actually uses up the raw material, natural gas, which have the main source of methane. And the product of it is obviously methanol. So what's the use of methanol? So first of all, methanol is actually a very highly toxic and flammable liquid with boiling point lower than the room temp. So it's actually a liquid and it's colorless. For methanol, it can be used as a feedstock to produce organic compounds, for example, formaldehyde, acetic acid, DME, and also MTBE. Second, methanol can also be used as a source of fuel because methanol is flammable and with the low percentage by mass of carbon, it will normally burn with less soot, so it's somehow a clean fuel, although it's toxic. And last but not least, methanol can also be used as a solvent. Thus, it can be added to ethanol to give the methylate spirit, which is used in the industrial solvent. So here show a general idea about the methanol production in industry. First, after the natural gas is being input, it will be passed to the desulfurization device. For the desulfurization device is actually very similar to the fossil fuel part that sulfur impurity will be removed such that it can also avoid poison the catalyst in the reaction. And secondly, there's steam methane reforming, which allows the reaction between methane and steam under certain conditions and presence of catalyst to produce a synthetic gas. So for the synthesis gas, or the syn gas, is actually a mixture of gas called hydrogen gas and carbon monoxide. And after that, the gas are actually compressed and also have a conversion. For the carbon monoxide and hydrogen gas, which is actually the syn gas, but you see, originally it's 3:1 ratio and now it's 1:2 ratio, sorry, originally hydrogen gas to carbon monoxide is 3:1, and now hydrogen gas to carbon monoxide is 2:1 ratio. Is that if we can change the mole ratio there and also compress it in another reaction condition of different temperature, different pressure, and also different catalysts, they will be converted into methanol. So for this change or this conversion for producing methanol, also have some remarks why this temperature have to be used. For example, when we increase the pressure, the equilibrium position will shift to the product side. Because the yield of the methanol increase, because the number of mole of the gaseous reactant is greater than the number of mole of the gaseous product, and hence the equilibrium position will shift to the product side. And also the yield of the methanol will increase. But when you increase the pressure, it will also increase the cost of maintaining and constructing the equipment. Second, when you increase the temperature, it will shift the equilibrium position to the reactant side because the forward reaction is exothermic. So, the yield of the methanol will decrease. But when increasing the temperature will also increase the rate of reaction. Hence, in short, while balancing the rate of reaction, the yield of methanol, and also the cost of the maintaining and constructing the equipment, there is an optimum temperature and pressure to proceed this reaction. And for this catalyst, there's also some history about it. In the past, like in 1922, there's also another catalyst was used, and it will have another operating pressure is like 300 atm and temperature is 400 degrees Celsius. And after some years, some decades, there's a ICI method that can use another kind of catalyst. And for this catalyst, the operating pressure can be reduced to 50 to 100 atm. So it's changing from 300 atm to 50 to 100 atm, and with a lower operating temperature from 400 to 250. And hence, if we apply the ICI method, it can actually help to reduce their operating temperature and operating pressure, which somehow reduce the cost of the experiment. So more method can be used. And nowadays, there's also some other advancement of technology of methanol production. First of all, there's direct conversion of methane to methanol with the use of metal oxide catalyst at high temperature and high atmospheric pressure. The conversion used a catalytic reagent. Second, instead of using natural gas as the source of methane, we can also use biomass to convert into syngas to make methanol production. The conversion will be more renewable. The conversion will use renewable feedstocks. So the key is like when we go back here, the natural gas normally we use as a source of methane is actually a non-renewable source. If we can provide the methane with a renewable source, such as from the biomass, then we can actually do it in a renewable manner. And next, the carbon dioxide in the flue gas can be converted to form methanol. The conversion will also help to reduce the release of carbon dioxide to atmosphere, which will cause global warming. So with the use of carbon dioxide converting to methanol, okay, it will actually, there's another way that can turn into methanol. Okay, but traditionally we have this process for carbon monoxide plus hydrogen gas to form methanol, and nowadays there's also some other method that turn in carbon monoxide into methanol, and this will actually help to reduce the release of carbon dioxide, which can somehow reduce the impact of global warming due to the excessive amount of the carbon dioxide in the atmosphere. And last but not least, oxidation of methane to methanol by microbial reaction. And the oxidation can have a higher energy efficiency. So there's actually different routes, different chemical reaction pathway that will produce methanol. And these four are some advanced technology of the methanol production. So this is actually very short introduction about methanol production, and here are some HKDSE past paper that you may try to complete. If you have any question, please leave a message in the YouTube. See you. Bye bye.